We're now going to turn our attention to some other factor method operators that are defined in Project Reactor's Flux class. Earlier, we talked about some of the core factor method operators like just, from, iterable, from array, and from. These are all operators that create fluxes in various ways. We're now going to turn our attention to three other factor methods: create, range, and interval. We'll start with the create operator. The create operator is used to create a flux that's capable of emitting multiple elements synchronously or asynchronously. The parameter that's passed into create is quite interesting. It's a consumer that's parameterized by a subclass or an instance of something known as a flux sync. We already know what a consumer is. Consumer is something that's a functional interface from Java 8. But what's a flux sync? A flux sync is a wrapper API around a downstream subscriber that can be used to emit any number of next signals followed by 0 or 1, error, or complete signals. The create method returns a flux that emits all the elements generated by the flux sync. This is probably a bit confusing at this point, so let's take a look at an example to see if we can make it a bit more coherent. So this is an example that comes from one of the utility classes called Reactor Utils that we have in the various examples and the case studies for the course. And in this case, it's a method called generate. And the idea of generate is to take a supplier parameter, which has a get method, and a count, and then to go ahead and use the flux.create factor method to generate count number of calls to supplier.get. So let's go ahead and see what happens when we use this code. So what we're going to do is we're going to call flux.create. We're going to pass in a lambda expression, which takes a flux sync parameter, which we call sync, and it goes into a loop that loops for I equal 1 to I less than count. And every time through the loop, we're going to call supplier.get, which will then generate whatever we want to generate. And we're going to go ahead and then emit that using the sync.next method. So that'll go ahead and pass that emitted operation or that emitted data value down the stream. We're then going to call sync.complete after the loop exits to indicate downstream that we've shut down, and the downstream should also treat that as the end of the computation. The elements can be emitted from one or more threads. This example here used the main thread of control or the calling thread of control to generate the signals. However, as we'll see later, you could have a background thread using something like subscribe on or publish on actually do the emission in a different threading context. There's a similar create method that's part of RxJava in part of its flow class or flowable class, and it works very much like the create method on Flux. However, the parameter types are a little different. Instead of passing in a flux sync, as we do for flux create, this passes in some type of emitter. And it's not important for the moment, but just be aware that there are some differences in the type system, which can be a little bit confusing if you try to port your code back and forth between RxJava and Project Reactor. These create methods are also very similar to the generate method that's defined in Java streams. So you can see there's a generate method that comes baked out of the box with the Java stream interface. And what it does is it takes a lambda expression or a method reference. In this case, it's a lambda expression, and then it just generates the results of calling that lambda expression or method reference over and over and over again. This particular example will generate a stream of random, large, and unreduced big fractions. If you wanted to bound the amount of processing that this did or the number of times it ran, you'd have to use some type of filter operation that we'll talk about later, like a take, for example. Let's now turn our attention to another factor method called interval. Interval can be used to create a flux that emits long values starting with 0. And it takes a parameter which indicates when to increment a value at the specified time interval. So in this particular case, the parameter is called period, and it's of type duration. So that means it could be in seconds or milliseconds or microseconds or so on and so forth. Interval returns a flux that will emit these increasing numbers from 0 to infinity, potentially, at regular intervals, which is designated by the period parameter. The interval operator will emit values by using the schedulers.parallel scheduler. And we talked about new parallel in a previous video. We'll talk about parallel later, but basically the idea is this allows things to run in a pool of threads that do computations in parallel. There's other overloaded interval methods that can take a designated scheduler. So if you don't want to run in the schedulers.parallel scheduler, and you want to designate your own unique scheduler or your own custom scheduler, you can do that with other methods that are defined in the interval class, or in the interval method or operator that's defined in the flux class. Under normal conditions, a flux that's using interval will never complete. So here's an example where we're going to generate a stream of longs every half a second in a background thread. So you say flux.interval duration.of millis 500, and that says generate values starting at 0 every half second. And we'll look at this example a little bit later. Since in practice, you rarely want to generate things infinitely, sometimes maybe you do, but you often don't. What we're going to do here is we're going to use the take operation in order to only process up to S max iterations of these intervals that are being generated from that background thread. So in this case, we can put a bound on that, even though in theory, interval will go on forever. The RxJava observable interval method works the same way as the Project Reactor Flux interval method. Again, you can see we can say observable.interval, give it a duration. It's actually a slightly different type, but same basic idea. And it'll generate the values incrementing at that period or that interval, that duration. And then in this case, we're only going to take a certain amount of them. The third and final factor method we're going to talk about in this video is called range. And you can use this to build a flux that will only emit a sequence of count incrementing integers starting from start. So count is one of the parameters and start is the other parameter. So this will basically emit integers between start and start plus count, and then it will go ahead and complete. Start is included in the range, but count is excluded. What this does is it returns a so-called ranged flux that contains the count elements that are being generated. You can basically think of the range operator as something along the lines of a reactive for loop. So here you can see that we want to do something for 10 iterations. So we say flux.range 1, comma, S max iterations, where S max iterations is 10. And whatever comes after that will then be done that many times. And of course, you can control that value through whatever means you have to set that. And we'll look at that example here shortly. RxJava has a range method as part of its observable class that works exactly the same way. Same basic idea. Both these methods from the reactive streams frameworks are very similar to the stream range closed method. So here we can go ahead and emit S max iteration integers starting at 1 by using range closed with int stream. So again, very similar concepts across the different frameworks that we have for modern Java. So that's the end of our discussion of another round of factory method operators. You can see that we have quite an assortment at this point. We've talked about 7 different factory method operators, and we'll get a chance to explore how they get used shortly.